Okay, question number 2. We have the temperature in a room for the first third of an hour after the heat is turned on. Express the derivative as a hybrid function. Okay, so that's going to be 30, and that's going to not equal the endpoint because you can't have a derivative on the endpoint, and that's not equal to 1/3. It's going to be 0 when t is bigger than 1/3. Okay, number 2, find the average rate of change. So the average rate of change will be f of a half minus f of 0 over a half minus 0. So f of a half sits at 22 minus f of 0, 0 is 12, divided by a half. And that's going to give me 20. Question number part C. Another model of temperature of the room is given by this. Find the derivative of that. Okay, 22 minus 10 you brought e to the minus 6x. Yep, that looks good, and I'll take the derivative of that, calculate derivative, first derivative, okay, and that gives me g dash of t equals 60e to the minus 6t, or you can write 60 over e to the 6t, either is acceptable. Find the value for t for which the derivative is equal to 10. So 10 equals 60e to the minus 6t, so t equals 10, solve for x, and what are we doing, decimal places? 0.298626, 3 decimal places, t equals 0.299. Part D. Find the time between 0 and 1 where the temperature predicted in the models are equal to each other. So, I want the temperature and predicted to models between 0 and 1 when they're equal to each other. So, one problem I have is between 0 and 1, we have one rule for t going from 0 to 1/3, and another rule when t is bigger than 1/3. So I don't know when it's going to be equal to each other. And I want 1. Okay, so let's have a little look at the graph of this one. So edit, clear all. Let's little look at this one. Up to 22. Never gets to 22. So it has to be before. So let's check that again. So let's do this equals, and that other rule is 12 plus 30x. Let's find out where it's equal to each other. .265. So if I was to graph this one, and this one, I do get an intersection point analysis. G solve intersection, that's at 0, and if I jump across, that is at 0.265, which is less than 1/3, so that's correct. 1 mark. T equals 0.265, 0.27 to 1 decimal place. The time when the difference between the temperatures between the bottle is the greatest. So what I'd like to do is I'd like to take 12 plus 30t minus 22 minus 10 e to the minus 6t. And I want the graph to be the greatest. I think the greatest is going to be about here. So I'm going to make this one and make that one positive, because after 3 seconds, so we'll do it F max. Calculation, F max of this, where I've got minus that and minus 30x, and I'm going to do an F max of that, comma for x between 0, 1, close bracket. And in decimal, I get the maximum distance is 1.5, and that's at x equals 0.11. So maximum 1.53426 at x equals, or t equals, 0.115. And the question said find the time, so t equals 0.11512 will be the time. So that's A3.